right, guys, so we're going to pick up with lesson 9.5 on sine and cosine. So let's just review a little bit of what we know and then add just a bit to it today. Okay, so tangent we talked about, first of all, we were talking about a right triangle. I'm going to call this vertex A, B, and C. And we named each of the sides of a triangle different things. So this is always known as our hypotenuse. Now these are my legs when we think of Pythagorean theorem. But when we're talking about trig, it depends on what perspective we're taking it from. So for instance, if we're taking it from angle C, then we can say that this side over here is going to be known as my opposite side. Then we can say that this side right here is my adjacent side. And we already had that the hypotenuse is what it is, so that stays consistent. All right, so the ratio for tangent is, we said opposite side over the adjacent side. And that's abbreviated as opposite over adjacent. Okay, so no matter what angle you're taking it from, that's always the opposite over adjacent. So for right now, I'm going to write tangent, and I'm going to write opposite adjacent. So T stands for tangent, O stands for opposite, A stands for adjacent. All right, now we're going to learn two new ones. This is sine and cosine. So the sine ratio is a little different. The sine ratio is opposite over the hypotenuse. Okay, so again, it doesn't matter which angle you're taking it from, the ratio is always consistent. The opposite side, whatever that may be, over the length of the hypotenuse. And that's abbreviated, as you can guess, this over this. Okay, opposite over hypotenuse. So for that, I'm going to write S for sine, opposite hypotenuse. Okay, and then for the last one, cosine is actually going to be, the ratio here is adjacent over hypotenuse. Okay, so that's abbreviated as ADJ, kind of like adjective, over hypotenuse. So I'm going to write cosine, so C for cosine, the ratio here is adjacent over hypotenuse. Now you might be looking at this, and if this is your first time seeing it, thinking, those are very similar and very easy to confuse. So that's where possibly you've heard this at some point, but there is a nice way of remembering that, and that's so, ka, toa. So if we were in class, I'd have you say that like 5 times on your own. So why don't you try that right now? So katoa 5 times, just to get that in your head. So, kind of like you're sewing something. So make sure you say it right. Ka, like, I don't even know how you say it. Ka. And then toe with a little ah. Okay, so that's kind of how it's thought through. Now, I have a funny little story I'm going to read to you that might help it sink in a little more, and there's some silly math acronyms. So sit back, enjoy some story time. It's called The Legend of Sokotoa by Matthew Martinelli. So many moons ago in the Archimedes forest lived a young Indian girl named Sokotoa. As with all Indians of the Zenzenzenik clan, Sokotoa derived her name from a memorable event in her early childhood. One day her father noticed her sitting on a natural log, dangling her feet in the water and solving problems involving right triangles. He cleverly declared her name shall be Sok-a-to. However, his daughter heard him say Sokotoa, and the name stuck. Sokotoa studied for many years and became very proficient in mathematics. She probably would have become a famous mathematician if she hadn't discovered boys, especially Falling Rock. Sokotoa liked Falling Rock and convinced him to study mathematics with her. After a while, he got bored and said, I like angles to a degree, and I feel positive about whole numbers. I'll even do some addition. However, I feel the inverse of multiplication causes division, and I'm totally confused when you say pies are squared. Nevertheless, graphing is where I absolutely draw the line. Sokotoa tried to teach Falling Rock about the legs of right triangles, but he was more interested in studying her legs. Right before Falling Rock turned 18, he asked Sokotoa to marry him. She agreed to be his bride and put her studying aside. Before they could be wed, Falling Rock had to pass the trials of manhood. Every boy in the tribe had to complete this ritual to be deemed ready for the responsibilities of marriage. Tasks were uniquely created for each individual. Falling Rock's task required him to travel to Triangle Mountain and put ink on the tail of the parrot that sits at the peak. When Falling Rock and his tribe arrived at the base of the mountain, the elders supplied him with a few cooking utensils and a jar of ink for the parrot's tail. He bid them farewell and spent many days in the sun, becoming quite the tangent on his way to the peak. That was the last time anyone ever saw him. After a few weeks, SOHCAHTOA decided to go up the mountain to find him. A few thousand feet up, she found her lover's cooking utensils sitting over a fire. The high pot in use, hypotenuse, was a sign that she was on the right side of Triangle Mountain. She climbed to the top, but she didn't find the parrot. However, she did find a message written on a stone. Her mathematical sense found it ironic that on the stone at the peak of Triangle Mountain were the words, "Polygon." SOHCAHTOA descended the mountain and never gave up hope that she might find her lost lover. Even to this day, it is said that she is still looking for him. In fact, you can still see the sign SOHCAHTOA left on the sides of the roads in the mountains. Watch for Falling Rock. It's a silly story, but it hopefully just solidifies SOHCAHTOA, gives you a little context, and makes that little acronym a little bit more concrete. Okay, so with that in mind, we're going to move into the notes today. We're not doing all of lesson 5, but one thing I want to point out, sign is actually written S-I-N-E, but on our calculator, when we write it in notation, we abbreviate it to S-I-N. That's why it's called sine and not sin, because this is the real name. Cosine is really C-O-S-I-N-E, but it's abbreviated C-O-S. And then tangent, T-A-N-G-E-N-T, is abbreviated tan. So these are the abbreviations we use, but they actually come from these official names, okay? And I'd like to, in one of these lessons, give you a little background as to where they came from. And so you're not just wondering, like, well, who created these ratios? But for right now, we're just going to work with them. All right, so the sine and cosine ratios. It says the sine and cosine ratios are trig ratios for acute angles involving the lengths of the leg and the hypotenuse of a right triangle, okay? So they're going to talk about from angle A. So the sine from angle A is going to be, sine of angle from angle A is the length of the leg opposite of angle A over the hypotenuse, which we've already talked about. This is not new. We said the sine from any angle is the opposite side over the hypotenuse side. Opposite over hypotenuse, aka SO, right? The SO part of SOHCAHTOA. So opposite over hypotenuse. All right, now the cosine, the third core trig function, is the ratio of the adjacent over the hypotenuse. Okay, and we've already mentioned this one as well. We said the cosine of any angle is the adjacent side over the hypotenuse. So it's cosine adjacent over hypotenuse, the ka part of SOHCAHTOA. So they have that written here, just showing you, instead of writing it as SOHCAHTOA, it's written a little bit more mathematically, putting it as ratios of O over H, A over H, and O over A. Okay, and then again, here are the abbreviations we already mentioned. So let's try this example. I'd like to try example 1 here. They're asking us to do a couple of things. Find the sine of angle X, cosine of X, sine of Y, and cosine of Y, and then write each answer as a fraction and a decimal rounded to 4 places. Okay, so first we're going to do sine of angle X. So I'm going to write up here for me, not sine, I'm going to write SOHCAHTOA, just so I have that to reference. I know it's also right there. But so sine of angle X is going to be the opposite, which in this case is 20, over the adjacent, over the hypotenuse, opposite over hypotenuse. And the hypotenuse is 52. Okay, so that's my ratio. I can simplify that to 5 over 13. And then it also says put it as a decimal to 4 decimal places. So 5 over 13 is the same as 0.3846. Okay, all right, now let's do the sine of angle Y. So from angle y, my opposite side is 48. My hypotenuse stays consistent, it's 52. So 48 divided by 52 is going to simplify to give me a fraction of 12/13. We always want to simplify it just as normal math. And 12 over 13 is decimal point 923, rounded is 31. Okay? All right, now let's try the cosine. I'm going to do this with a different color. Cosine from angle x and then from angle y. So the cosine from angle x, the cosine is the ratio adjacent over hypotenuse. So my adjacent side is 48 and my hypotenuse is 52. So that actually should be familiar. We just did that with sine of y. That's going to give me 12 over 13, which is the same as 0.9231. All right, let's try the the cosine from angle x. So from, this should say y. I was like, we just did that. That should say angle y. Okay, so the cosine from angle y. So my adjacent side is 20, and my hypotenuse is 52. That's going to simplify to give me 5 over 13. And if I go ahead and turn that into a decimal, I get the same thing we had before, obviously, which is 0.3846. Okay, so something that you're going to notice, and that's what's written down here in this little section, is that the sine of one angle is equivalent to the cosine of the opposite acute angle, meaning that sine of angle x was equal to the cosine of angle y. So the sine of angle x is the same as the cosine of my opposite acute angle, and vice versa. The cosine of angle x is the same as sine of angle y. So they flip-flop. Okay, now we'll talk a little bit more about that in the next lesson, but I wanted to get that basis there. Okay, I'd like to set up 2 more and then we're done for today. Just example 3. Okay, so they're asking us to find the value of x and y using sine and cosine. So they're giving me this angle, so that's what I'm going to work from. So when I try to find x is from this angle. X would be my opposite side. This is my adjacent side, and this is my hypotenuse. It helps if I label that. So I'm going to say to find x, that means I'm going to have to involve my opposite side, and then my hypotenuse is the only number that's given. So I'm going to say the sine, because SOHCAHTOA, the one that involves opposite and hypotenuse, is sine. So I'm going to say the sine from 26 degrees is equal to x over my hypotenuse 14. Okay, and then I can go ahead and multiply both sides by 14. 14 times the sine of 26 is going to give me 6.here's 10th, they say, so 6.1. All right, now let's find the measurement of y. So from this angle again, 26y is my adjacent side. So I'm going to do adjacent over hypotenuse. So this is going to be cosine of 26 degrees equals adjacent over hypotenuse. Multiply both sides by 14. 14 times the cosine of 26 degrees is going to give me, round to the nearest 10th, 12.6. And it makes sense. If this is 12.6, and that's 6.1, and that's 14, it looks logical. Okay? All right, we have one problem left. This one here from 35 degrees. So I'm going to label what the sides are. This side over here is considered my opposite side from that angle. This is obviously the hypotenuse. And this is my adjacent side. All right, so to find x, excuse me, we're dealing with the opposite side, and the other thing they give me is the hypotenuse. So opposite and hypotenuse, that's going to be sine. So I'm going to go ahead and do sine of 35 equals x over 53. Multiply both sides times 53, and I get, round nearest 10th, x equals 30.4. And the last little bit, here I'm going to do cosine of 35 equals y over 53. I'm close to the end. 53 of cosine of 35 degrees is 43.4. All right, great work, guys. Thanks again. Bye-bye.